in this, so don't act the fool. All right. So we're going to be burning different metals. I'm going to tell you what metal we're burning, and then you're going to write down that metal on your, or that color on your little sheet. At the end, pay close attention. Pay close attention because maybe two of them will be orange, but they'll be different shades of orange. At the very end, I'm going to be burning two metals, and I'm not going to tell you what those metals are. It is your job to write down the color, and then it's going to be one of the ones that I have already burned. And so it's your job to compare those colors and tell me what metal I am burning. This is called a flame test. Flame tests allow us to figure out what kind of metals are in different compounds by the color they burn. This color comes from the same process that we saw in Unit 4, Section 5. That process of electrons being promoted because of energy intake, and then they fall down and release the light. We saw it with that with the light bulbs. But instead of electricity here, that energy comes from fire, from heat. All right. Now let me go get the methanol. I'll be right back. Now this is methanol. It burns very clear. It's a kind of alcohol, very similar to ethanol, but it burns a lot more clearly than ethanol. We're going to be using to burn our salts. What the heck? That's one of yours. Hopefully this works properly. We normally would do this on a Bunsen burner and you will burn the metals yourself. Um, but that because of Corona is not possible. So hopefully this will work just as well. Let me move some of these things so y'all have a good view. And if I need to go in because there's a fire, I can. So the first metal that we're going to be burning is copper. And it should be the first metal um in your list. Is it? Someone tell me now.
Yeah, it is.
Copper, this is copper nitrate. It's a very cool sapphire looking chemical. Now we're going to put a little water in here to dissolve it. And then we are going to add methanol to light it on fire. And hopefully this will work as intended. It's going to take a little bit for this copper to start melt or start catching fire and changing the color. So first you're going to see the blue flame from the methanol, and then you'll see or you'll see more of a pale, like clear flame. And then we'll see the copper. So give it a minute. So you can start seeing the flashes of color, right?
Yeah,
Yeah, it's
like
like kind of like green.
Oh yeah, I forgot that you're yeah. You can see it well on the camera. So you see that green, those green flashes. That's the copper. If you want to move, you can, because I know that's kind of weird angle. You can see it. Okay. So as the copper burns more and more, you're gonna start seeing more and more of that color. What you're
Mr.
seeing is the copper burning. Someone had a question online?
Yeah, do we say green flashes or do we just say like a greenish tealish color?
No, it's a greenish color. The flash. The reason why it's flashing as opposed to just being green is because the metal or the salt's burning on the top. So it's little. What you're seeing, those flashes are little pockets of salt that are burning. But eventually, if we let this go long enough, you see that the whole fire turns green. Kind of like if you ever saw Game of Thrones, the Fiend's fire from Game of Thrones.
Yeah.
No? And this is actually how they make different color fires in movies. I mean, sometimes it's CGI, but sometimes they'll use chemicals to turn the fire different colors. It's very used in special effects and in fireworks. Did this class? Oh no, this is a class that didn't get to see that. Yeah, because of the hurricane. Well, so that's a copper. Any questions? No?
No. So could we say that that's somewhat of a turquoise-ish color?
Isn't turquoise like blue green? No, it's more of
Yeah,
a
it is.
like apple green or neon green, lime green. Sometimes, well, not lime green. But all right, let's move on to the next one.
Here's turquoise.
So what I'm doing is I'm putting this bell on it because that's gonna choke out the oxygen and it's gonna stop the burning. It's a much safer way of putting out fires when you're doing chemical demonstrations. Because if I put any kind of chemical like a fire extinguisher or anything on this, it might actually react with the chemicals that I have here burning. So there's that. Let me, because that's gonna be hot. Where's my gloves? Oh, I'll put them back in there. Yeah. I'll put the small one on. So that was copper. Let's move on. The next one we're going to do is potassium. So the next chemical we're going to burn, this is potassium chloride. So it's a salt made with potassium and chlorine. And some of these are going to burn more clearly than others. Now notice, love safety, I'm keeping the flammable chemical away from the fire. Now I should they be wearing goggles? We're good. So let's do the next one. Isn't Miss Walker lecturing? Isn't Miss Walker lecturing? Listen about chlorophylls, man. You're in the wrong class. So this is potassium. Now the color in potassium is actually a little harder to see, so I'm gonna give you a bit of a hint. The reason why is what you're seeing is a bit of overpower from the Oh, you can actually see a lot better on the screen. Yeah.
Is it like an aqua blue or?
Not
Okay.
aqua blue. You said, so who said purple?
Me.
I think I can see
It
it.
appears to be somewhat of a lilac color.
What do you say?
Lilac. It appears to be somewhat of a lilac color.
Good, Gabriel. That was Gabriel, right?
Yes, that was me.
Good, Gabriel. It's actually it is a lilac kind of color. If I get in front of it, you see those purple wisps in the middle, like light purple.
Yeah.
Like lilac is the color. The official color, the official name is a lilac color. But you see it like down in the middle. It's harder to see here, and it actually looks whitish when you look at the fire because it's mixing in with light from outside. That's actually a really cool white. But it's mixing in from light from outside and the light from the methanol burning itself. But it's actually lilac color. You can see a lot better on the screen than you can on the fire. The fire itself looks white here because the lilac is so faint. It's actually really cool. We hadn't done it like this before, so I hadn't seen this. It's white. All right, so that's like a lilac color. So as you can see, potassium and copper burn very different colors, right? The copper was like a green. The potassium burns a lilac or white color. I'm gonna put a belt back on this. And that's gonna slowly smother out the fire. Like your hopes of getting an A in this class. I'm just kidding. Some of you will get an A. Not a lot of you, but some of you. All right. So that was the potassium. Let's do sodium next. And again, I don't want to burn myself, so I'm going to use gloves. Sodium will be next. Now, this one is something you find in your house. This is sodium chloride. Anyone know the common name for sodium chloride?
Table salt.
Table salt. Chlorine. Boy, you can't blame that on the color blindness. Like that's so sodium chloride is just regular table salt. This is the same stuff that you put on your food. This is lab grade, so it's a little more pure. It doesn't have all that hippie stuff of putting sea salt and white pink Himalayan salt, and it's just pure table salt sodium chloride. No, potassium chloride is found. The one that we just burned, the lilac one, is actually found in some common like salts. There's different salts. For example, pink Himalayan salt. I don't know the exact compound in it, but it has other salts in it. That's why it's pink. So other salts are quote unquote edible. Now, I'm not telling you to go and start licking chemicals, right? But they're edible in the sense that you can ingest them in small quantities, in what called mineral quantities, so quantities found in like nature, and they won't be harmful to you. In fact, some of them are good for you. Potassium iodide is added to salt, table salt. So whenever you get salt, it says iodized salt. That means it has potassium iodide added to it because our thyroid glands actually need iodide in our diets. But because of the type of diet we have as more advanced human beings, so we have stopped eating some of the stuff that we used to eat, we don't get as much iodide as we should. So that leads to something called what's a thyroid what's it called? I think it's hypothyroidism. So it leads to something called hypothyroidism where your thyroid gland gets huge. Thyroid gland, if you go like this, the little butterfly kind of knot that you have right on your throat, that's your thyroid gland. And that, if you don't get enough iodine, it leads to hypothyroidism, and this gets huge, and you get this lump, and it's very dangerous because your thyroid gland makes a lot of hormones that you control your body's functions. So we add potassium iodide into salt because everyone eats salt, and so that's one way that we eat other salts. Some people are actually allergic to it, and so you can also buy de-iodized salt, meaning it doesn't have any iodine in it. And in fact, some people are allergic to iodine. Most people who are allergic to shellfish are actually allergic to the iodine in the shellfish, not the shellfish itself. But this is the sodium. I'll give it a second. So you start seeing the flashes. I think I put a little too much methanol in there. So I'll wait till it burns down a little. There you go. It's starting.
Is that orange?
Yep. We get an orange. So it's a bit of like a yellowish orange,
I
right?
think that looks like
Like
more
a
of a bright
orange?
yellow to me.
Oh, well, that's because of the camera. It's a little too bright for the camera to pick up properly. But it's more of a light orange or mandarin, if you will. Trying to get some of the light off. A little like a mandarin or a light orange color. It's a bit too bright for the camera to pick up properly. Let me see if I stand away from it, if it's better. Let's see if I can focus. So no. Yeah, it's not gonna work. The camera is just a little too bad for this. But it's like a yellowish orange, tangerine orange, mandarin orange. Yeah, that's I didn't realize that because I didn't realize because I mean like the camera's lens is acting like the boric glass, and it's filtering out the other colors. That's why it's not picking up the orange so much because it's filtering it out. So this one, I'm not telling you to go burn stuff in your house, but if you're in a campfire and you throw a handful of salt into the fire, you'll see these little crackles of orange. And if you throw a pine cone into a bonfire, Be careful because you're not supposed to pick up firewood, and pine cones are considered firewood in public parks. If you have a bonfire and you find a closed pine cone, not an open one, but a closed one, those pine cones will burn a certain color because they have barium in them. The pollen from the pine cone has barium in it. And I'm going to show you what barium looks like in a bit. Okay. So you'll see what a pine cone will look like if you put it on there. We'll put that on.
Mr. Pendula, what material was this again?
Give me a second because Miss Jones Roberts is talking.
That was sodium salt, I think.
Uh-huh. So there's something called, I think it's called rainbow firewood. I know for sure you can buy a packet that you add to the firewood, but there's something called rainbow firewood where you get the firewood and it's lined with all these different metals or salts of the metals. So when you light your firewood, it actually burns a bunch of different colors. And it's called rainbow firewood. You can also buy a little packet that you just sprinkle on top of the firewood. What were you? Someone had a question on the Zoom?
Yeah, I wanted to make sure, what material was this again?
This is sodium. The thing is that salts are made of a metal and a non-metal. Everything we're burning, right? This is sodium chloride. So the metal was sodium, the non-metal was chlorine. The color of the fire comes from the metal, not from the non-metal. So you'll notice a lot of these are either chlorine or nitrate based, the different anions, which you'll learn about later in the year. And the reason behind that is because they burn cleaner. So that was sodium. Next is lithium, one of my favorites. Y'all better appreciate this because I had to grind down this lithium to hell. It's really, lithium comes in rocks. It doesn't come in a
Oh, yeah,
powder.
that's one of my favorite Nirvana songs.
So this lithium nitrate. Lithium nitrate comes in rocks instead of a powder. So you had to grind it down.
Gabriel, you're not muted.
So let's look at this one. Again, this is lithium. The salt itself is lithium nitrate, but the metal is lithium.
Is that pink?
Yep. It's like a hot pink. It's a little harder to see because it doesn't burn as vigorously. Hopefully it's gonna pick up in a second. You can actually see pretty well on the screen.
Is that magenta?
It's like a magenta or a hot pink, yes. Really
Yeah,
cool
looks-
color that lithium burns. That's why you go through the trouble of actually grinding this thing down every year.
Yeah, it looks more crimson red to me.
This works a hell of a lot better than the actual lab. Yeah, no. Last time we tried to use methanol in the lab, someone lit a table on fire. So we stopped. What's up? If you're to grab the fire itself, like with a branch or something. So no, if you were to transfer the fire over, right, the tree will burn according to whatever wood it is. Some woods burn like a lighter orange, some woods burn like a darker orange. What's actually causing the color? So what's burning here is actually the methanol, but the methanol gets hot enough that it burns some of the solid salt. That's what gives it the color, the burning of the solid salt. Once you put this on a tree, that salt isn't there anymore. So you don't get the color. So the fire itself is not colored. The burning of the salt is. Fire is a bit of a weird state of, well, not even state of matter. It's, yeah, it is a state of matter. It's plasma. It's what it is. What fire is. So what you are seeing is not the fire. It's the light coming from the salt. And so the fire is just taking on that light. Yeah, that's a hot pink. I'm gonna close up before it starts. Once these get low enough in methanol, it'll start crackling and splattering everywhere, and we don't want that. All right. So that was lithium. What is next? Calcium is next. So we're gonna do calcium now. We need to call McCoy and be like, he needs to observe us now. We need to call McCoy and be like, can you observe us now? Well, you can if you want. This is calcium. Oh, okay, that's fine. Because yeah, I didn't know what I was sitting there. I'm like, there's so many colors I could write down. This is going to be calcium that we're burning. This is calcium nitrate. The salt is calcium nitrate. Calcium is actually kind of cool. Its crystals are more crystal than powder. Even if you grind it, I actually ground this down. It's a bigger crystal. They remain very kind of like translucent, very almost diamond-like. They're obviously not diamond. They're not as hard as diamond, but you can see the shine, the glimmers. All right, so let's burn this one. I don't know why I'm using matches. I don't know why I'm using matches. Yeah, we have a million different lighters, but so here's one of the kind of downsides to the flame test lab, right? A lot of these chemicals are going to burn very similar colors. They're not exactly the same. It's very similar to the way that when we saw the lamps, some of them have very similar colors. Some of the fires are also going to have very similar colors. This one takes a little bit because the crystals are bigger, so they take longer to light. So let's give it a second. But you start seeing the flashes in there. I put too much methanol. So, is that smoke or is that no? That's gonna oh yeah, it's smoke. Huh? They just water vapor. It's from
Is
the
that
methanol.
calcium?
This is calcium, yes. I'm waiting for it. I put a little too much methanol, I think. You can see the little flashes, but you can't really see them on the screen. I should have done this in the background. But then the camera would have been. I should have done this on the back of the room, but the camera would have been too far away. Give me a second. What happened? You go out? Oh. Okay, let me actually before I do that. Huh? Oh no, I'm just. Now I'll put more calcium in it. I'm adding more solids. Hopefully, it's a better color. Oh, show warm gloves. Don't do this at home. What the? Oh, shoot. Hydroscopic. Mm-hmm. It's absorbing all the water from the air. Can you bring me another one of the petri dishes? So one of the problems we have with calcium nitrate is something called hygroscopic. It absorbs water from the air and dissolves itself. And that's why it's not burning very well because it's full of water. You can see the colors a little better now. The blue is from the methanol. So what other color you see?
Pink.
Red?
It's like a reddish orange. It's like a brick orange or a clay orange. Must see if we can do another one later. But so the issue we're having here is that it's actually putting out the flame itself because it's absorbing water from the air. And we're in Miami, so there's a lot of water in the air. And I need that one because I need well, I don't know what that's a different one, but it's deeper. But yeah, I think it's the top. So you see it better now because I added more before it's been sitting overnight, and that's why it was full of water. So you can see that brick red a lot better. I actually need to let this burn a little because I filled it up a little too much. I'm gonna use calcium chloride for the next one. Yeah, well, not for like for the next class because it'll burn better. Oh, there you go. Oh, now it's going well. What happened? Methanol is just an alcohol, and most alcohols are flammable. So methanol is made of carbon, oxygen, and hydrogen. It's what we call an organic compound, and most organic compounds will either burn a blue or orange color because of what they're made up of. So this is like a brick red. That's just from the lack of oxygen that it turned that color. It's like a reddish orange, brick orange, or clay orange. It's another term that's used for it. Okay. Remind me to like wash my hands before I eat. Where is I think this is it. So that was calcium. Next we are gonna do barium. Now remember I told you barium is in pine cones, right? So this is the color that pine cones will burn if they're closed, meaning if they still have some pollen in them. So pine cones, what they actually are, they're not seeds, but they're in the same kind of like structure. And so the little bristles you see on pine cones are actually usually closed. And what happens is that when that pine cone is ready to pollinate, those bristles open, and if they're male bristles or they're male pine cones, they'll open, and inside there's all the pollen, and the pollen will get picked up by the wind and distributed, falls into female pine cones, creates flowers, etc. That pollen is what has the barium in it. So if the pine cones open, there's no pollen in it. So these have to be like more fresh pine cones because the pine cones will open and then eventually fall off the tree. So this is barium chloride, another one that's very shiny. It's a powder in this one, but it's a very shiny powder. Not pine cones. Barium is used a lot for Halloween decorations. Where's the other one? Here it is. Oh, dang it. A little bit of methanol. Yeah. Plastic. So we have the methanol, light it on fire, and you'll see what pine cones will burn like. Now this is usually the messiest one when it burns.
This is
Barium.
correct?
Yeah. Give it a second. Let's start get it going. And you can see little flashes already, but should get better as the methanol gets burned off. It's actually a very yellowish green. It's like a lime yellow. Yeah, you gotta wait for it. I mean, very yellow green, but like there's a little green in there.
Is it like a booger green?
Oh, like a lime green, like a really pale yellow green. Booger green, really?
It's a color like a Crayola color.
It's a what color?
My lord.
It's a Crayola color.
Crayon color.
Girl, there's mac and cheese crayon colors. Like, I don't think crayon colors are the official. So you can see it, it's like yeah, you see more yellow than green in this one. That's kind of weird. I thought he said that. I'm like, well. You see red? Aren't you red green colorblind? Oh. So it's like a yellowish. Yeah, I mean, right now it looks yellow, but it's supposed to be a yellowish green. It's a very faint green, but it's not coming through with the methanol.
So, do we put yellow or yellow is green?
Put yellow green. I mean, we'll take both answers, yellow and yellow green.
Okay.
The blue is from the methanol. Yeah. Well, that's fine. We can put yellow. I'll close that one. If you do the pine cones, you'll get more green color because pine cones have a barium borate is what the chemical is called, and that one burns a much more greenish hue. That's barium. I think everyone's wearing masks. A black fire? No, you can get very dark, like purple fires with different chemicals, but you can't really make a black fire because fire is, in essence, light, whereas black is the absence of light. The last one we're gonna do before we do the unknowns is strontium. Where's my strontium? This is strontium, and it's very, very powdery chemical. So again, a little bit of water. It is not a spell, it's a chemical. It's an element. So again, you start seeing first the little sparks as it burns. And then as it gets closer and closer to the salt, we'll see more color. Salmon red? Someone's pink. So
Scarlet, I think.
it's like a, let's see how to describe this.
Scarlet. Scarlet.
It's like a scarlet color. Again, the camera is not doing it too much justice. Trying to see if I can put anything behind this on a burn. So the camera's not doing it too much justice, but it's like a scarlet color. Let me see if I get closer if it'll pick it up better. Nope, that's worse. And again, the camera is gonna be tricky because the camera's gonna pick up different colors depending on the type of camera it is and the lens. So everyone see that? Now notice how it burns too, right? It's not just burning calmly, it's crackling. The different salts will burn in different ways. The strontium nitrate tends to crackle when it burns. That's what you're looking at, those little sparks. All right. We'll put that on. Let it die. So now we're gonna look at two unknowns. We're gonna look at two chemicals. I'm not gonna tell you what they are. You are free to discuss color. I don't want anyone saying anything on what chemical it is. All right, you're free to discuss color for the sake of the people on the Zoom and those of us who are not so color proficient. But please do not say anything on what chemical it is, because that is your job to figure out as a young pseudoscientist. So first, we're gonna do unknown A. Like I mentioned, there are two colors, two unknowns, and we just call them A and B. So this is unknown A. Huh? Yeah, this is the same as one of the ones we already burned. It's your job to figure out which one by looking at it and comparing the colors. Give it a second. Give it a minute. Remember to actually also check the camera color. Sometimes they're better, sometimes they're worse.
Is that purple?
It's a very light purple, yes.
Seems to be somewhat of a lilac color, I think.
Mm-hmm. Your observations are correct. It's a lilac color.
Could you say like a lavender?
Yes, a lavender is correct. You are supposed to stay here because of the because like that's where they have you as right now because of like contact tracing and everything. So I can't really send you somewhere. So we go with that one.
Yes.
Did you say no? Oh. Hey, let's put the ball on it. And this is why they always call it a ball jar. As you can probably tell from its shape if you've seen that. Thank you. So that's unknown A. So you're supposed to tell me what chemical it is. And now unknown B. It's back here. Say that again. That doesn't really matter. I don't even remember what I put on the thing. Oh, I mean, we can take both of them. I don't care which one they use. All right. So this is unknown B. Oh. It's the quickest way to dry methanol. With the fire on it, my hand will charge for. Oh, nothing. You can just wipe it off and it'll evaporate. But this is cooler.
Hot pink.
Um, Is this hot pink? No, it's more of a red.
Like
More of a
orange.
red.
Is it scarlet?
Yeah, like a scarlet color. Let me move it more to the center. So it's like a scarlet red color.
Yeah, that does appear to be scarlet.
And these are the downside of cameras is that they don't catch everything the eyes do.
Hmm.
Sometimes they catch more, sometimes they catch less. And if you're really quiet, you can actually hear it sizzling. All right. So that's your flame test lab. Yep. Make sure you submit it once you have filled out all the questions, because otherwise you won't get a grade for this. Any questions, comments, concerns, life crisis, emotional breakdowns? No?
I think we're good.
All right. Well, that's it for this presentation. Someone turn on the lights, please.